Okay, good morning everyone. So today I would like to introduce the different concepts which are present in the third unit, that is combinational circuits. See the slide showing the content in the third unit. Actually here we can identify three different parts. First one is about the combinational circuits, second one combinational circuit blocks, third one is data storage elements. That is in the beginning part, that is in the first part case, we can see what are the various digital circuits are available, different logic gates and minimization, developing Boolean equation using Boolean algebra, minimization techniques also we can observe here, and implementation based on the truth table maybe. Then in the second part, that is combinational circuit blocks case, you can see the basic building blocks for the combinational circuits like decoder, encoder, multiplexer. Okay, so like that. After that you can see certain mini projects like home alarm system, digital safe system, car park occupied slot counting system. Like that we can see certain higher level of digital circuits using these basic blocks. Then in the third part you can see what are the storage elements are available like latches, flip-flops and registers, memory units. Okay, so and also after discussing those concepts we will develop the VHDL program for all the combinational blocks and also basic storage elements like latches and flip-flops. Okay, so this is about the content of the third unit. Then coming to first of all for a digital circuits, in the digital circuit generally we have two types. The total digital circuits are categorized as two. One is a combinational logic circuit and another one is sequential logic circuit. Okay, so two categories of digital circuits we can see. One is combinational logic circuit and another one is sequential logic circuit. So what is the difference between these two circuits means, in combinational circuit case, the output is a function of only inputs. The present output is function of the present inputs. Whereas in the sequential logic circuit case, the output is not only function of present inputs or current inputs, also depends on previous outputs or previous inputs. Also depends on previous outputs and previous inputs. Okay, so that is the difference between sequential and combinational circuit. Okay, so coming to sequential, since the output is not only present on the current inputs, also depends on previous output or previous inputs. So it includes along with the combinational circuit, a storage element also it includes. Storage elements. See here I have shown one block diagram of sequential circuit. It consists a combinational circuit and a memory element. Okay, memory element is the storage network. Okay, so it has to store the previous state, that the previous value, previous output, maybe previous output depends on the inputs. Okay, so like that you can take the block diagram difference between combinational circuit and differential circuit, and definition wise you can define as the combinational circuit case the output is just a function of the current inputs, whereas in sequential circuit case the output is not only depends on the current inputs, also depends on previous outputs or previous inputs. Okay, so like that you can differentiate the digital circuits as two, combinational and sequential. But all these digital circuits designed using logic gates. Here I have represented four logic gates. Now one is NOT gate, OR gate, AND gate, XOR gate, like that. Okay, So for this not gates, already you know the functionality of each and every gate. I think you studied in switching theory and logic design. Now just I would like to introduce how to develop the VHDL program for each and every gate. Of course I will discuss only a few gates in different models maybe. Coming to, here is the program, here is the VHDL program for the 2 input AND gate, for the 2 input AND gate. Okay, so already in previous sessions we have seen the VHDL programs for different digital circuits, right? Now let us see first of all for a 2 input AND gate how to write the program. Okay, so first of all here I am going to write the program in the data flow model. Data flow model of architecture I am going to represent here. As you know, as usual, the first statement is library IEEE. Library IEEE. You have to choose one standard library. Then from the library standard package you have to open. That is called standard logic 1164.r. Package name is standard logic 1164. Okay, in that package all the definitions which are there, those are all in open mode in this case. Then after writing these two, for every VHDL program case we need to define input ports and output ports through entity declaration. Okay, you can define input ports and output ports through entity declaration. Okay, see here for entity declaration for the 2 input AND gate. 2 input AND gate means how many input ports it has? 2. How many output ports? 1. Okay, so entity AND2 is the user defined name is, that is usually first line in the entity declaration. It starts with the word entity followed by entity name, that is usually digital circuit name, that is 2 input AND gate is. Then port of all the 2 ports I am declaring in the single line, so that's why x comma y colon in standard logic. Okay, so that means x and y ports are the input ports to the system and they can accept binary type of data. Okay, actually in standard logic case we have 9 different values. Out of those 9 different value, any value the system can be accepted. And one output port that is named as Z, so Z colon out standard logic. Okay, then end entity name. End entity name, what is the entity name? AND2, so end AND2 semicolon. Okay, after that architecture body. So I said already architecture body I am going to write here in the data flow model first of all. Okay, so therefore as per the model representation I am giving the name for the architecture, and as per the syntax you know the architecture starts with a word architecture, then df means data flow. So that means I am going to write the program in the data flow model of entity name, that is AND2 is, then begin. Okay, architecture begin, because no declarations here, that's why directly I am writing the begin. After begin, in the data flow style, what type of statement I have to choose? That is signal assignment statement. Signal assignment statement, its appearance is similar to Boolean equation. Boolean equation. Okay, now tell me what is the Boolean equation for AND gate case? Z equal to xy. Okay, Z equal to xy. So what is the operation between x and y? That is logical AND operation. Okay, now the statement is Z less than equal x and y, x and y semicolon. So end architecture name. So like that we can represent the data flow style of architecture for the AND gate. Okay, then coming to another model. Okay, so it is not another model, this is the program for 2 input NAND gate. 2 input NAND gate case, almost the same program you can take, but here not AND operator, NAND operator you have to place between x and y. Okay, and then I am going to show the program for XOR gate in the behavioral model. Okay, so whatever the model of architecture representation, but before that we need to use library, and you have to open the package and declaring the entity. Okay, now to input XOR gate I have taken as an example digital circuit. So what is its entity declaration? Entity XOR2. XOR2 is the name of the digital circuit, is port of two inputs named as X comma Y in standard logic, and output is named as Z out standard logic, and end entity name. Okay, and XOR2. Okay, now let us see the architecture body. So for architecture here I am going to represent in which model? Behavioral model. Okay, so I said in previous classes, behavioral model, to write the program in the behavioral model, better you should have the information of digital circuit in the form of truth table. Okay, in the form of truth table. If you know the truth table, then you can easily write the behavioral style of program. Okay, so first of all, architecture BEH of XOR2 is begin. Then begin means there is no declarations. That means immediately after architecture begin represented, no declarations. Okay, then in the behavioral model, what type of concurrent statement? That is process. Okay, so process of sensitivity list, that is here generally the sensitivity list are inputs. So X comma Y, then process begin, after begin the statements in the process. Okay, this begin is related to process, not for the architecture. Process begin, then in the process the statements are what is the statement here? Sequentially executed statement. That is what type of statement I am going to take here? If statement. Okay, so if X equal to Y, then Z equal to 0, else Z equal to 1, as per the truth table of XOR gate. In XOR gate case, you know, if both the inputs are equal, the expected output is 0, otherwise it is 1. Okay, do you remember? The truth table of XOR gate is, from the truth table of XOR gate you can understand that if both the inputs are equal, the expected output is 0. Otherwise it is 1. Okay, so simply I am checking if the inputs are equal or not. If the inputs are equal, then assign the output with 0, otherwise the output with 1. After that, end if you have to write what happened here? End if you have to write end process, you have to write finally end architecture name. Okay, that is also mistake here. End VEH. What is the architecture name? VEH. Okay. Anything else? Okay. So some few mistakes are there here. End if you have to write after assigning the Z value with 1, then use or you write down end if. After end if, end process you have to end process, then end architecture name. What is architecture name? BEH. Okay, so those corrections you made here, you make here. Okay, so that is about the architecture representation in the behavioral model. Like that, for any logic gate, by taking the truth table information, you can develop the program in the behavioral model. Okay, so now I am going to stop this session. In next class I will see the next topic. Okay.